Hello everyone, my name is Wen Zhendai from National Indian University of Science Technology, Taiwan, Republic of China. And today I will present you about RF receiver DSRC chip design with antenna. Outline: I will introduce the paper background, the board diagram of RF receiver front end, the proposed long-range amplifier circuit of receiver front end, the proposed double band lens mixer circuit of receiver front end, the proposed voltage control oscillator and the bandpass filter, antenna design and the measurement result, performance comparison, discussion and conclusion. Finally, we will the reference list. Introduction: the proposed radio frequency receiver front end applied in 5.8 GHz DSRC of ADAS application is presented in this paper design from the TSMC 0.18 CMOS process. The low voltage front end chipset design adopt the long-range amplifier of using current user circuit and the Gilbert cell mixer of user current injection technique. The mixer signal from the closed coupling LC tank voltage control oscillator with input matching balun. The matching result of integrated circuit adopt in input return loss of minus 25.3 dB and conversion gain of 25.15 dB. Double side gain noise finger of 4.1 dB. The IP3 of minus 16.5 dBm. The proposed layout dimension of the receiver front end, including the pad, is 1.24 by 1.03 mm squared, with power consumption of 12.9 milliwatt from 1 volt supply voltage. This slide shows the board diagram of RF receiver front end. We have including the each path, and part of the proposed LNA long-range amplifier circuit of receiver front end. The proposed double band mixer circuit of receiver front end. We have a layout transformer by ourselves, and the proposed layout of Balun, the proposed layout of bandpass filter, and the proposed voltage control oscillator circuit. We have a built-in to control the capacitor value and fine-tune the tune range. Voltage control oscillator layout and the placement. And we have input the matching balun with the Trans-Conductor. And the die photo of the RF receiver front end placement. Die size is equal to 1.24 mm by 1.03 mm squared. We have a combined receiver and also including the VCO together, and we have a measurement in the acoustical chamber with antenna. So the machine measurement result of parameter S11. We can see in band now 5.8 GHz, and we can get the S11 summation and the measurement result. And this summation and the measurement result for the parameter CG. And we have a summation and measurement result of parameter double sideband noise finger. And the summation result parameter IP3, we can get the result. And this is the measurement result for parameter IP3. And measurement summation and measurement result for the parameter local oscillator to the IF isolation. And this is summation and measurement result for the parameter local oscillator to the radio frequency isolation. And this is a machine and measurement result of parameter radio frequency to the RF isolation. And antenna design, we're using the PCB design. So we have using the feasible PCB put-in the circuit substrate to design the size is 8.6 by 4.5 millimeter squared. And this is the antenna design, the 2D the radiation pattern in our chamber. And the other direction also check. Also combined together, we have a proposed conversion table with the other published based on the measurement, so we can get the FOM is higher than the other published, and also check the noise finger and IPS read and power consumption. This is our comparison table with the other published. And in conclusion, this paper proposes a low voltage RF receiver front end chipset design and topology from the TSMC 0.18 CMOS process. The proposed cascade current injection can reduce power consumption, and using the current use to also have reducing the noise, both balance mixer and enhance the conversion gain. Our VCO using the closed coupling LC tank VCO with the balloon. So this is impedance matching the balloon. That's all. And summation the measurement proposed. The proposal RF the receiver front end in comparison with the other published. And this was proposed excellent proposed of input return loss of minus 25.3 dB, conversion gain of 25.15 dB, double sideband noise finger of 4.1 dB, IPS read of minus 16.5 dBm, with the die size of 1.09 millimeter squared, with the power consumption of 1 to 0.9 milliwatt from the 1 volt supply voltage. And this is the design at low cost and low power RF receiver front end for the DSRC of the ADAS application. And this is our reference list. And thanks for your listening. If you have any question, you can answer question me. Thanks all.